Namaskar. So in this lecture, let's discuss about how you can utilize determinants and matrices and solve a system of linear equations, and that's the application where we are going to utilize that well. So here we'll talk about that what are the conditions when the solution will exist for a given linear equation, or when it is not, and if it is existing, that how you can solve it. So let's see. So let's say we have a system of equation a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3, right? So now you know that this can be written in the form of a matrix, as you had discussed when we are talking about matrix in the previous chapter. So you can write it as a1 b1 c1, a2 b2 c2, a3 b3 c3, right? And then here you can write the variables x, y, z, and that can be written equal to d1, d2, d3, right? The same thing can be expressed like this, and you will have the similar value. So it would mean that you can write a like in a matrix equation where a x is equal to some value b, right? Where this is the matrix which is determining that it will have solving solution or not. This is the variables and this is the value y, right? So this is called a matrix equation, and the method which you will be using it that would be called matrix method to solve this kind of problem. Now as we had seen that this matrix, the matrix A determines that whether it will have a unique solution or not. So there can be two conditions. One is that let's say A we got here from this, it is like the A1 B1 C1, A2 B2 C2, a3 b3 c3, right? This is the determining matrix. Now if you have a condition such that the determinant of A is not equal to 0, right? So that we just saw that kind of matrix would be called a non-singular matrix, right? It means the A inverse exists. So in this case, if you write the matrix equation AX is equal to B, so if inverse exists, then you can multiply at the left side of the both. So you can have AX is equal to A inverse B. This now you can follow the associative law. So you can write AX is equal to A inverse B, right? So this implies IX is equal to A inverse B, implies that you can now find the x value which will be A inverse B, right? So see how usually you can now you can know that x value, it means you know the x, y, z, and whatever matrix of the inverse and the B given, you find that would be the value and compare the each element with this, and you will have the result of those. So if this is the condition when determinant of A is not equal to 0, right? So this concept you can utilize to find that. Now here you are utilizing the concept of determinant and the matrices and finding the inverse of it, so to determine that what would be the solution of such equations. So this is the case when we are talking about determinant of A is not equal to 0. Now the other case arises when A is equal to 0. This kind of equations where you have a determinant, they are called inconsistent system. And in such case you can have two points. If you find that the value where determinant A is equal to 0, in that case you find the value of adjoint A and multiplied by B, if this is the equation, right? This is the equation, right? You have some equation AX is equal to B, and then you have this determining factor A is equal to 0, then it have this equation system will be called as inconsistent system, and in such case you can find adjoint at B, product of these two, and if that is coming out the condition 1, that is not equal to a 0 matrix, right? If they are not 0 matrix, so it would mean that the solution doesn't exist, right? Solution does not exist, right? And the system would be called inconsistent system. Now the other case can be that the adjoint of that given matrix and product of B if is equal to 0 matrix, right? So in that case there can be two possibility. One, either infinite solutions or no solution, right? So it can be two cases. So it means that now if you are getting an equation where you are finding the determining matrix, the determinant is 0, in that case the two possibility you can check. If the adjoint of that matrix multiplied by the matrix B is giving you a 0 matrix, in that case there can be infinite solutions or have no solutions. Again, it can be consistent or non-consistent, right? So it have a infinite solution, then it is a consistent system. If it has no solution, then it is a inconsistent system. But in case if they are not equal to 0 matrix, then no, it is always an inconsistent system. It does not have any solution. So this is how you can check now if the determinant of a given matrix is 0, then this condition for a given matrix equation Ax is equal to B, whether there will be solution or not, and if it is there, then how many solutions you can expect. So this is about that consistent system, inconsistent system, and what are the how you can utilize it to solve a matrix using a matrix equation. Now let's see example, and then we'll end this part. So let's see. So let's say you are given you solve problem and then you end up like two equations, something like this. Let's say this is 2x plus y and 3x plus 2y, right? Now you need to solve it, right? So now if I want to write in a matrix form, let's say Ax is equal to B, then how I can write? So I can write 2 5 3 2, and here it will be xy is equal to 1 7, right? So this would be my A, this would be my x, and this would be my B, right? So the solution can be written as Ax inverse B if determinant of A is not equal to 0, right? So first of all, let us find out what is the determinant of A. So determinant of A is equal to 4 minus 15 is equal to minus 11, right? Which is not equal to 0, right? So it means it is a non-singular matrix, not singular matrix, right? So the solution will exist, right? So now let's find out that then what would be the value of x. So here it would be A inverse B, right? So A is given. So what is A we have here? We have A 2 5 3 2 2 5 2 5 3 2 here, right? So what would be A inverse? So A inverse would be determinant of A adjoint of A, right? So determinant of A we just calculated. It is how much? It is minus 11. So you can write minus 1 upon 11, and the adjoint of A would be, you have to calculate, right? So what can be the adjoint of A in this case? So you have to find A11, A12, A21, A22, right? So this would be equal to your, for A11 it would be this 2, and this would be leaving this minus 3 and this minus 3, right? For this element it would go, for this element what would be 2 1, right? Minus 5 will go here because row column is interchanged, and for this it would be 2, right? So this is what you get as a the adjoint, right? Adjoint of A, right? So you can have minus 1 upon 11, you can multiply 2 minus 5 minus 3 2, and then this is a matrix here, so you can just get multiply this again. You have this for solving this x is equal to A inverse B, so you multiply it, right? So what would be the value? A inverse you got now minus 1 upon 11, 2 minus 5 minus 3 2, and then you have B. What is the B value here? 1 7. Now you solve it, so you get x is equal to xy is equal to minus 1 upon 11, you get minus 33 11, and this is the matrix, so each element will be divided by 11, so you will get 3 minus 1, right? So now you can matrix, you can compare each element equal, so it will become 3 y is equal to minus 1, right? So see how easily you can utilize this concept of matrix equation, and the formula, if they are not this matrix is a non-singular, then you can easily solve it, and what would the value you can find out. So you can similarly you can fly for even a higher order examples, and you can easily solve this kind of problems, right? So here what we all need to know, you need to find determinant, adjoint, and then you can easily calculate, and you should know what is the matrix multiplication. So this is all about that application utilizing determinant and matrices to solve a matrix equation, and also lots of unknown variables. So if you have a system of linear equation, you can find out, right? So this is all about this application of matrix. Now in next lecture we'll discuss about summary of the whole chapter and see in some the related concept what we have reviewed in brief. So that we'll discuss in next lecture. So see you there. Thank you.